within the client. I kept on working off stream on that. I made a few changes. So rather than just setting a play sound component, which I was doing, I now have it also. 1 second. I think I do have an issue with Twitch. No, with YouTube. Oh, here we go. YouTube is now connected. Sorry, I am not sure whether or not YouTube has been synced all along, but we do now have a YouTube connection. So I was setting a play sound component in order to let the troll play sounds on the client. I ended up changing that. I'll pull up some code. I changed it so that rather than sending a play sound component, it was setting a client action component. Now that lets us kind of choreograph things more on the client, so the timing of what happens on the server isn't as important. I also got the animations working yesterday. I was expecting to do that on today's stream, but it turns out to be a lot simpler than I was expecting. Now, if I can do a demo, you can see he just kind of stands there and holds his weapon. As we come up and get closer, he will take a swing at us. Sound's not working for some reason, but ignore that for now. I've got something wrong with my configuration, I'd say. Oh, I see what I've done. I don't have my headphones plugged in. So, yes, he's now animated. It's all a bit hacky, but it works. There we go. Now, that was pretty much everything I was hoping to get working for this week's development devlog episode. So today I thought I'd move on to getting the actual troll moving a bit. Now, there's a couple of different aspects to that. One is to actually get him moving around the terrain. That's going to take a fair bit of work. I'm not going to get onto that today. So today I'm just going to do the poor man's version and have the troll turn to face the player. So that is my goal for today. Now I'm just checking that everything is all working. I'm just going to mute myself. Well, mute my audio. Just going to quickly check that we are indeed live. Yes, we are. Excellent. Okay. So, where do I start? Again, off stream, I improved my vector class a bit. I just kind of added some functions that I know I'm going to need. I also chose a library that I'm going to use to do a lot of my rotations and things like that, because it's all going to be done using Quaternions. And there's a pretty good Quaternion available on NPM. NPM Quaternion. Go. This library seems to do everything we need. I assume it supports TypeScript properly. But it lets me take angles between vectors. It lets me rotate vectors, and that's pretty much everything I'm going to need to get the troll rotating. Okay. Where are we? I need to install this. All right, so just to recap what the current AI code is doing, it currently tries to find a player within range. It updates its aggro target. For anyone who was wondering, there was a bug, or what looked like a bug yesterday, where the troll, it looked like it was lagging out really badly. I ran up to the troll and it wasn't attacking me. That was actually this code doing exactly what it's meant to do. The troll had actually aggroed on a previous instance of the player. And when I close the client, I actually leave the player entity in for 60 seconds. So it was still aggroed on the other player, just it has no way of getting to that other player. And it was only once that player got deactivated that it finally aggroed on the real player and started attacking them. So it wasn't actually lag, it was the aggro system doing exactly what it's meant to do. So if we have an aggro target, then it considers attacking them. And if they're within range, it attacks them. So what I'm going to do here is I'm just going to do a calculate the angle to the aggro target. So we're going to get a bit into the weeds here with the maths. I will be working with quaternions. It always takes me a while to get my head around quaternions every time I get back to them. Don't worry too much if you don't understand this. Sorry, I've not been paying attention to the chat. These only came in a few seconds ago. Jay Slecken says, is the 60 seconds to prevent players from just dodging combat? There will be a system to stop people from dodging combat, but that's not why it's there at the moment. The reason it's there at the moment is because I keep on stopping the client and the server in the debugger, and I want to give myself enough time that sessions don't time out while I'm debugging. So that's the reason for the 60 seconds at the moment. When players become persistent, because players are not at all persistent yet, once they do become persistent, I will need a mechanism to stop players from just dropping their connection to avoid a fight. Hello, also Dogs Cray Cray. Okay, calculate the angle to the aggro target. Oh, what I was saying as well is it's going to bring up a window over here. I very highly recommend 3 Blue 1 Brown if you want to understand quaternions. He's got a 2-part series. I will just link to his... Does he link to his videos in here? Yes, he links to his own videos here. If you want to get a proper understanding of quaternions, I recommend having a look at that video. Don't do it now, of course. Stay for the stream. I will make sure I explain exactly what I'm doing with them, though. So how do we calculate the angle to the aggro target? We first of all need to know... Hello, Conrad. Welcome. We need to know what direction the troll is facing. We need to know what direction the player is from the troll, and then we need to take the angle between those two. Seems pretty straightforward. So let's actually go const angle to target is going to be calculate angle to target. We'll take the entity, which is the troll, and we'll take the aggro target, which is the player. Let's just get a method created for that. Function, sorry. We'll do that globally. Source and target, and we'll just make that any for now. Can I get IntelliJ to convert this to a... No. Just going to make this a const. Is equal to that, goes to there. I just prefer the style of using constants rather than first-class functions. Okay. So, angle the source is facing. Now, the way we get this is we need to take the take the forward vector. I've got a... Where's that? Do I not have... Oh, I need a name. All right, facing is going to be equal to vector3 dot identities dot forward. So that's the forward vector. Now, I need to multiply that by a quaternion. For memory, I need to do quaternion times the forward. So we need to know const source rotation is going to be quaternion. Let's go and grab our example code here. We need to convert from the Euler angles, which we store in the database. And I'm not sure if that's the right thing to store yet, but I want to go quaternion from Euler. In fact, I'm almost certain that Euler angles isn't the right way to store it. Why is IntelliJ not letting me do that? Because this is not... I added the Quaternion library to the coordinate module, but I've not added it yet to the ticker project. Not sure if that's going to be the issue. Ticker, Quaternion. Add that in. Is that going to let me do it? Import. There we go. Then we come back to here, ourselves a bit more space. Okay, so we've got Quaternion from Euler. Now this takes 3 parameters. They do Z, X, Y. Now, one of the issues with Euler angles being used to store rotations is the order that the 3 components is applied in is absolutely important. Now, I don't know what Unity uses as its ordering for Eulers, and I don't really care all that much, given that all of our stuff at the moment is only rotating on one axis. So I'll just assume that it matches whatever this library is expecting. And so in here we can go source dot transform dot rotation dot, what do they say, dot Z. Z, we've got X, insert Y. Now, if I take that source rotation dot, and then I rotate a vector, and I do the forward vector, it's not going to like that. And the reason for that is, it's XYZ in Unity. Thank you very much. So I'm not sure how to get this library to, the order can take a string value, for example, XYZ. I assume the interpretation of these stays the same. So I will just specify that as XYZ in here. As I said, it won't matter at the moment because I'm only expecting rotations in the on the y-axis at the moment, given all of our mob entities are kind of vertical. Oh, wait. I'll look it up. Unity Euler angles order. ZXY was right. Excellent. But yeah, it doesn't matter because, yeah, if you look, do I have the client open at the moment? It doesn't matter. I'll run the client and I'll just kind of show why it doesn't matter about the ordering at this point. And when it does matter, it's also not going to matter because I'd have no intention of using Euler angles. It's they're just an extra step in all the computations. Might as well just store the quaternions in the first place and send them over the wire. So the rotate vector is expecting an array of x, y, z, whereas I store vectors as structs. So I'm just going to put a method on here, public as array. It's just going to return this dot x, this dot y, this dot z. So on here, I can do as array. Still doesn't like it. Yes, that's fair enough. It explicitly wants an array of 3, which we have to do. There's more a tuple, I guess, once you start specifying it like that. All right, so I think that gives us our facing vector. I'll be able to test that later. Next, we need vector. This should be the vector the source is facing. So now we need the vector to the target. This one's a lot easier because in this case we just do to target is going to be equal to target dot transform dot position. I'll convert that to a let's just convert that to a vector. That.z. I'm sure there are better ways of doing this, but this works for now. And then I've got minus, and then might as well make this a constant because we're going to need a couple of different positions here. So let's do const target pos is going to be equal to that. Const source pos is going to be equal to source, and source. Welcome back, Ifman. So it's fairly quiet in here when I started the stream. So just to recap, I've got animation working. I've got all the server to client code working. And so now I'm working on, that was everything I wanted for the next devlog episode, which will come out on the weekend. So now I'm working on the following episode, which will be the mob moving around. I'm starting today just handling rotation of the mob before I get into the actual pathfinding. Pathfinding is not going to be fun. Target pos minus source pos. So that gives us a vector from the source to the target. Here, I believe we have a vector which is pointing forwards relative to the from the troll's perspective. So now I think I can just do Quaternion. There was some angle from between vectors. Okay, so let's do const tween is we want to go from the facing dot from the facing to target. This one needs to be as array. Now, if you understand quaternions, one of the really useful properties of them, they have 4 components. And they have 1 real component and 3 imaginary components, and it can take some getting your head around. I do recommend watching the 3 Blue 1 Brown episodes to get your head around how that rotation happens. But one of the great things is those 3 imaginary components actually specify the axis of rotation, and then the real component specifies how far the rotation happens. So I can pretty much guarantee, because if you were to assume that the terrain were flat, the quaternion that comes out of here is going to have its imaginary components being just the up vector, because we only need to rotate to get from the way the troll is facing to where it needs to be facing to see the target. It only ever needs to rotate around the y-axis. So the imaginary components will be approximately up. Regardless, all I need to do to return the actual angle between these, I think, I could be wrong here, is just to return the between dot. Does this have like a real? It does. It has a real. And I believe that will return the angle needed to rotate to get from where it's facing to where it is facing. Now, this doesn't take into account the difference between vertical angle and horizontal angle, which might be important to the AI. Quaternions are our imaginary friends, once you can finally get your head around them. Okay, that might work. What I'm going to do for now is just log that. So let's just do a log dot info angle to target angle to target. Oops, what did I just do? There. Okay. I wonder if that'll work. Of course, I have no idea if this is in degrees or radians. I assume this is in radians. Let's put this down so that we can see the debug. Now, if I'm standing directly in front of the troll, I expect the angle to be approximately 0. No, it's 1. That's not a good sign. As I come around, comes down. Oh, got too close. Okay, I don't know what I've done wrong here. Time to debug. First thing I can do is throw a breakpoint in while the player is standing in front of the troll, and just see what those different vectors are being set to. Let's just see, what direction does the troll face? Scene. That troll. He currently has no rotation. So that's good. That will make it easier to debug. We will get ticker service debugged. Just stop the server over here. Restarted the debugger. All right, the code is running. So let's grab angle to target, and then we'll step through. Got our source position. Looks like a fairly reasonable coordinate. In fact, I remember setting the troll's position to that. And we've got our target position. Seems plausible. Source rotation, I'm expecting to be a quaternion with in the up direction. So I'm not sure how they represent their quaternions, but I expect this parameter to be a 1. It could be anything. The real component should be 0. Source rotation, let's see. That's 0. That's 0. That's 0. I might be misremembering what the real component is good for. Let me just double check the documentation. Dot real, do they... Real W part of the quaternion. Angle. I'm not sure that that's going to help me. So what I'll do then is I will just double check that I'm understanding this part right. Let's go source rotation dot real is 1. Okay. Yeah, it's nice when Unity does things for you. So yeah, I don't fully understand why the real component is 1. I was really expecting that to be 0. I'm probably misremembering something about quaternions. So now we can do an 8. Oh, I guess the real component is kind of arbitrary at this point because the X, Y, and Z are 0. So it's like not being rotated around any axis. All right, the to target is hopefully a forward vector. So it's going to have a Z component, I think. And yep, it's mostly Z component. A little bit of Y. I'm obviously up a bit higher. Then we grab between, and between is a quaternion that okay, so I'm obviously misremembering how to interpret a quaternion. That's a bit annoying. So let's come back here and do a bit of a Google. Quaternion get angle of rotation. What does this say about axis angle? We've got a from axis angle. They have a to axis angle. Well, Okay, how are they defining their Quaternions? They are defining them as A, B, C, and D. A is their real component. Singularities, we'll ignore the singularities for now. If anyone knows the right way to get the angle of rotation, would be appreciated. Bouncing all over the place here. I mean, will this... I'll tell you what I can do. A better way of doing it at the moment, just while because I don't want to bother working out what I'm doing wrong here, I can of course do between dot to Euler and just return the y component to dot, which is it's not pitch. So hang on, pitch is like that. Roll is like that. Yaw is like that. So we want the yaw. So this will just return the horizontal rotation, I believe. So if I let this continue, that looks a bit better. So our angle to target here is 0. Every time I think I remember Quaternions correctly, I always find out that I'm wrong. Okay, so we're getting minus 0.3. Over here, we're getting... Just move this around a bit. Okay, here we're really close to 0 when we're right in front of the troll. Right, yep, really close to 0. As we come around, so that we're out by 90 degrees, this looks like... One, if we're all the way behind the troll, 7. 2.4, I'm getting very... It seems to be impacted by how close I am, does it? What on earth? I think that I've had a stale session mess me up there. So let's come back around here. It is 0. Come around to the side. It's now, what's that, about half of pi? Come around the back. Seems to be 0 again. Yeah, so I can't just take the yaw. That's unfortunate. So this is going to have other components in here that that it's compounding to get the... sorry, just thinking slowly. Yeah, it's got other components that it's composing with this to get the rotation that it wants. So it might be flipping the model over before it does the yaw. So much for that. to Euler. This angle. I'll get there eventually. Fortunately, it is definitely not something in the library, something the library can do for me. So I do need to find the actual maths to get the rotation from the Quaternion. All right, let me just do a little bit of reading here. Yeah, this looks plausible. So if the real part is not actually the rotation, if it is instead cosine of half the angle, that would make sense, right? Because I was expecting the angle to be 0 before, and that real component came out to 1. Cosine of 0 is 1. All right. So let's go const angle is going to be double the math.arcos cos of between dot real. All right, hopefully this works. The troll does have an... Oh, yeah, sorry, you've seen the troll having an idle animation. It also has an attack animation now. I realised there weren't many people in when I did the... Oh, it might not work now that I've just broken all my code, but... There we go. So yeah, he also has an attack animation. Doesn't line up very well yet. What on earth is wrong with this? Oh, I'm not returning it. Return angle. Oh, this is going to still be growing on the old player, unfortunately. So, what's the best way of getting rid of him? I'll just do get a list of all of these. Let's see, the troll is aggro on this player. So I'm actually just going to do a delete on that. We'll delete that player out. He should now be aggro on me. The player won't get removed from the client. That's just a bug in my client at the moment. But the server should now be updating that angle correctly. Target is 0.5. If we come around to his side, increases as we come all the way behind him. It's approaching something looking kind of like pi. Seems a bit small, doesn't it? Oh, it's because we're raised up. Yeah, so just a recap for you, Ifman. I've finished off all the work that I wanted to do for this weekend's episode of the devlog. The troll is animated. He's got sound. It's all controlled by the server, but it's choreographed now by the client. And so now I'm working on stuff for next week. My goal, sorry, for the next episode after this coming one, my goal for the following episode is to have the troll able to chase the player. And so right at the moment, I'm just working on getting him rotating to face the player and limit his attacks so that if you're behind him, he can't attack you. And then after that, I'll start working on having him actually navigate this terrain. That's going to be fairly challenging. I need to do that all in TypeScript. Oh yeah, I got too close. But none of the animation code was done on stream. That was all done yesterday afternoon. It was much less effort than I thought it was going to be. I thought it was going to take me most of today's development stream to get that working. But it was, the animation stuff only took me about 10 minutes. So there was nothing really to do on stream for it. Okay, so I think that this is at a point where I can say if he's close enough to if the player is close enough to the front of the troll will attack. If the player sneaks up behind the troll, then he won't attack. So let's try that. Okay, so we've got the angle. Let's get rid of this stuff. Don't need that. That's just taking up space. Angle to target. Let's hide that. And I'm just going to say for now that the troll has an angle of attack of up to 45 degrees. I guess I can probably even put that in as a parameter on him. Attack angle. Let's just say 45. And I'll store that in a new copy of the troll in a moment. So if the target distance is within attack range and angle to target, which I think is in radians, so times by 2 times by 180 over pi, I guess, to get it into degrees. That angle to target. I want the math.abs of that is less than agent.attributes. What did I call it? Attack angle. Then he can attack. So let's try that. I'll need to recreate the troll. And off screen that I can use to put a new instance of the troll in. Then I'll grab the actual troll here. Put him in. Check that took. Attack angle is 45. And then see if that worked. So if I walk up in front of him, I should get attacked. Nope. Oh, it's a bit delayed. I'm not sure what that was. Let's just try again. Why is that so delayed? Something's not right here. Why is he not attacking me? Hey Griffith, how's it going? Just to fill you in, I'm kind of done with animation and sounds, moving from the server to the client. So that was everything I wanted for the next devlog episode. So next, I am working on getting this troll moving. The very first step is to get him to understand direction. The goal for this stream is to have him turning to face the player, but also unable to attack players that are standing behind him. Good news is that part's working at the moment. Unfortunately, he's stopped attacking players in front of him as well. Oh, there we go. He's attacking me in front. If I come down behind, he doesn't attack me. As I come around, yeah, something is really wonky here. I think most of the nasty maths is out of the way. And for interest, the way that I didn't go the way I didn't solve that the way I'd normally solve it. Uh, Normally, if I have something that I'm not understanding about something like quaternions, I'll just go off and read about it. I kind of find that hard to read while I'm on stream, so I instead just went and poked around and hoped I'd find a simpler solution. But yeah, in the end, I just had to read how to get the angle out of a quaternion. And it's not something you need to understand. It's good to know that you can get the angle out of the quaternion. You don't really need to understand what's going on under the covers. I like to understand it, which is why I posted the 3 blue 1 brown link earlier, because that's great for understanding quaternions. Okay, so what's going on here? Something is not right. I'll put that log message back in. Info, angle to target, angle to target. Let's also grab well, let's do the conversion up above. Just do the conversion like that. I think that's right, isn't it? So we divide by pi and times 180. I'm pretty sure that's right. Abs that. Then I'll grab this. Max angle, max attack angle. We'll call it max attack angle. And put that in there. Once max attack angle. Yeah, learning quaternions before all the YouTube stuff was there, it's actually really interesting, and why I love the 3 blue 1 brown videos. There's really two ways of thinking about quaternions. There's the purely mathematical way, and then there's the intuitive way. And what's his name? Greg Sanders, something like that. He does an incredible job of making things like quaternions really intuitive. I keep having to go back to it though, which might not be a good sign. Agent.angle attack. That makes sense. Something just died. That's right. So I'd say I saved with a compile error, and that has crashed my server. My AI is definitely not running anymore. All right, let's stop that, restart it. Apparently I'm using lots of experimental stuff in TypeScript. Target, max, max attack. Let's get that in. Now if we get within range, all right, he attacks. Come around behind him. He does not attack. Come around in front of him. He attacks. I don't know what was going wrong before. That's looking absolutely fine. Okay, so that's a nice little result. Perfect. So next, I'm going to add some code to allow him to actually turn slowly to face the player. So if you do sneak up behind him, if he's aggro to you, he will turn around and attack you once he can. So we've got the angle. after he's decided if he'll attack, let's do the rotation after that. The aggro target is more than, let's just say 10 degrees. Forward. Now, I've got to be careful here. The problem here is that the angle, if the person is on terrain, the person may be either above or below the target. So if I just do this and say, oops, what have I just done? If I just have the troll rotate according to the Quaternion that comes back, then he'll end up tipping over if you get too close to him or something like that. So I do need to be careful that I only process the yaw for the rotation. It's more than 10 degrees from forward. Rotate. Give me 1 second. Sorry, just a quick cough. Now, I'm not really sure how to get the yaw. I don't want to convert to Euler angles. All right, let's just do it naively for now. I do need to know the direction of this angle, so I'm going to get rid of the math.abs for now and add that back down here. We need to know which way to rotate. And I'm not going to bother with any logic actually yet. I'm just going to say rotate to face the player. Keep it simple. And then I'll add more constraints in a moment. So we have we can get the trolls rotation Quaternion. And we want to rotate him to face the player. I could probably just keep this really simple for now, couldn't I? If I were to just ignore the y coordinates and recompute all the angles, I think I'll get a really, really simple solution to this. Yeah, so Griffith, just to show you what the code currently looks like for calculating that angle at the moment. It's my calculate angle. So I do just take the position of the troll, the position of the player, and then take the two vectors. That's the two vectors, and then take the angle between them. And the bit of code I had troubles with, because I misremembered how the real component worked, was this bit of code just here. I forgot it was the inverse cosine. Okay. So rotate to face the player. I'm just going to do this out in full. Const source pos is equal to a new vector. But I'm going to take the entity. Oh, we've already got the entity location. But I need to get rid of the y component for now. Just because I can't be bothered trying to work out how to do yaw using quaternions. Const target pos is going to be equal to new vector3 target location.x. Why doesn't it like that? It doesn't like the .x on the entity location. Oh yeah, that's not going to work. entity dot location x, entity dot location dot z, target dot location dot x, comma 0. It's not target, it is aggro target. Aggro target dot location dot z. Still doesn't like it. Because it could be null. Yeah, I'm just going to assume that that is set. Oh, it's not the location, it's the transform. Back to this one should be the transform as well. Yeah, nice. Griffith, I do intend to have a look for better libraries. One of the reasons I'm doing this fairly kind of bespoke is because I just kind of want to get my head back around how to do geometry. It's been a while since I've done this stuff. Dot position dot x. Is that gonna, what are we doing? What? Transform. Sorry, slightly distracted there. Aggro target dot transform dot position dot z. All right, so I've now got our two positions with the y coordinates zeroed out. So that will let me do the processing in a planar fashion. Okay, so I'm not going to calculate the troll's facing. All I want to do is make the troll point towards the player. So const desired direction is going to be equal to target pos minus source pos. Then I need to know how far to rotate the forward vector to get there. So const desired rotation is going to be a quaternion dot, I don't know, from between vectors, vector 3 dot forward, and desired direction. Well, there's a better way of doing this. I'll just take the cosine or something here, but whatever, this will work. Desired direction dot as array. And then do I just grab the Euler angles now? Desired rotation dot to Euler. Again, I don't actually want to be using Euler angles in the entity store. I want to be using quaternions. So in here, I'm going to set the entity dot transform dot rotation const y colon, no, the yaw. I'm only going to use the yaw. Let's just do it like this. Rotation dot y is equal to that dot yaw. Okay. So now I should be able to push that through to the server. Let's just make sure it makes sense first. Log dot info desired yaw, and that is going to go that. Excellent. My ticker service has gone down. I've obviously saved with a compile error. Okay, desired yaw is 0. That's not sounding right. Rotation. That's definitely not right. Let's just see what it is doing here. If I just set that to pitch, is it just that I'm passing the wrong parameters into it? So we should have a valid-ish looking yaw now. As we come around in front, it should stay around 0. It's about 0. Comes up positive, and it comes up through to pi, hopefully. Nope. Nope. This is because I should not be using Euler angles. Okay. So what I'm going to do is I'm just going to do that same trick again. I'm just going to say desired rotation dot real. I'm going to take the math dot acos of that. It's 2 times that. So I'm just extracting that angle the same way. I'm just going to assume that the axis is pointing up here. As we come around here, it should come up to pi. That looks pi-ish. And back to 0. Okay. I am removing the y component from both vectors. That is being done just in here. Am I passing the right thing through to them? Direction between forward, which I'm sure it just has a z component. Yes. Yes, so I have already removed the y components. I should probably be doing that up in the actual calculate angle code as well, because, yeah, at the moment I really don't want the terrain to be an issue. But I'll get to that later. Pi-ish, yes. Okay, so I have the new transform rotation. I now need to send that through to the server. I think I just set, do I have an updates? Updates.push. And then I need to give it an entity update. Yeah, we need the entity ID is going to be the entity.id. Never remember what format I have these IDs in. I probably shouldn't be using 8 different IDs. where do we send our... I might actually just do it like this. If we come in through here, then I'll do state changed equal to true. And rather than push aggro state, I'm going to push entity state. And in here, I will send through the actual transform. Transform has a position, which is entity dot position. In fact, I can just do the entity dot transform on here. I think that will work. Sending through too many updates to the server, because every time it considers attacking, it will go and update the agent state as well, but it's just a null operation, so it should be fine. Okay, what does he do? He doesn't turn to face me. Now, that could well be the client code. Let's see how the troll looks on the server. Previously, he had rotation of 0, 0, 0. And I am now... This is meant to be global rotation. Why am I considering his existing forward direction? Okay, I'll resolve that in a moment. Am I setting his rotation? Yes, his rotation is being set. It's probably just not updating in the client. Yeah, Griffith, on the topic of entities calculating their own update messages, I do intend to do that. There's a... I know the pattern as the data proxy pattern, and it's what's used by, for example, Mongoose, if you're using it locally, where whenever data comes out of a database, you store a copy of it, and then you just ask the database to save it again, and it goes and looks at what it previously retrieved out of the database compared to what you've changed it to. And that way it can calculate what deltas are needed to be sent through to the database. And I do intend to do that. But I need to know exactly what operations I need before I can do that. Otherwise, I'll end up spending too much time writing bits that I'm just not going to need. Okay. But yeah, having these kind of updates being generated all over the place is just such a mess. And it's starting to get a bit unwieldy, so I'm going to need to do something, even if it's just factory methods for now. But ultimately, yeah, I want those entities calculating their own deltas. This must be a client. I'm going to say this is a client bug. C# code. So when a remote entity comes in, yeah, I'm not sure what the actual name of the pattern is. I just know it as the proxy pattern. And it's probably me being slightly tainted by sort of Java-style web apps where libraries like Spring Data, which is one of the most common database layers in Java web applications, it calls it proxying, value proxying, or object proxying. So I think that name comes from the Java world. Convert rotation. Let's just get a breakpoint in here. Connect the debugger. We're not connected? We're not connected. I have no idea what's going on here. I'm just going to close Unity and restart it from inside Rider. Oh, I don't have breakpoints enabled. That might have been it. Just going to mute my output for a second. You can still hear me. I'm going to check. I just realized I've never actually checked that the Twitch stream's working properly. Oh, and you can see all the YouTube comments in the Twitch stream as well. Nice. Very nice. I better close that before I turn my audio back on. There we go. All right, so this is running again. Let's get the client in. There it is. And then I'll re-enable breakpoints. And that looks reasonable. So I'm expecting this to be XY. I'm expecting this to be a Quaternion with some W component. It's 0x, 0z, and 1y. It's I think that's true for simple rotations. It's my key combination, or just want to do inspect, evaluate. Nope. Let's try that again. Right click, evaluate. There we go. There's some W component, although that's very small. Ah, this is going to be a degrees problem, isn't it? Yeah, so just to explain my thinking there, why does it keep doing that? Right click, evaluate, evaluate. So I mentioned, well, I saw in the documentation before that, of course, a W value of 1, that is the cosine of an angle. And so this suggests that we're having a rotation very close to 0. It is around the correct axis. But the fact this is close to 0 suggests that this is using degrees, whereas our server, I'd say, has stored radians. So, and we do want to be using degrees in the communications protocol at the moment, because, well, that's what I'm using. So let's just get this going again, close all of these evaluation windows out, and make sure that the server, what's it storing? Well, yeah, that's storing radians. Okay. So let's come back to where the player gets attacked. And let's make this, it's going to become 360 times that divided by math.pi. I should actually make this better documented. Hold on. That's a bit confusing. It looks like I'm getting my radian formula wrong, but I'm not. Const radians is going to be equal to 2 times that over math.py. No, 180, there. 180. And then this whole thing, hang on, what am I doing? I'm slowly insane here. And then we'll do a 180 times by radians. There you go. So it's a proper conversion. Yeah, and that should be a common function, but I'm lazy. Okay, my AI has crashed. It has crashed. So let's spin the AI up again. Okay, he's rotating the wrong way. Oh no, there we go. Yeah, this lag is not real. It's only because I'm running my my ticks so slowly. Otherwise, it's impossible to debug things. Oh, he's facing the wrong way. Why is he doing that? So he works over this side. He's doing a Zoolander. He can only turn one direction. Okay, that is straight out bizarre. I'll just double check my code manually. What have I got? So I've got the source position. That's the troll. The target position is the player. Desired direction is a vector from the troll to the player. And then the desired rotation is how would we have to rotate the forward vector to get to that desired direction. I've got a feeling this is going to be something to do with a sign, like a positive, negative. The angle is 2 times the inverse cosine of the real component. And then convert to degrees. I don't see the problem. Okay, is it something to do with the sign of something? Come around here. He's facing us. Check his stats. And he has a rotation of 121 degrees. If I come round to where he stops facing us, we get, seems, oh, it's probably as I've gone past 180. Okay. Where's the furthest that he can face us? That's kind of facing us. I reckon this is going to be close to 180 degrees. And yes. If I come around the other way, I reckon he can track us around to here. And then somewhere around here. That's about it, I think. Well, let's actually see him mess up. There we go. He's messing up now. And we now have a look at our troll. And surprise, surprise, he's close to 0 degrees. Okay, so I'm having troubles with the rotations from 180 to 360 degrees. I have had a problem with Unity's Quaternions before. Yeah, I'd say that's absolutely it, Graphic. I think the Quaternion is turning upside down. The way I've fixed it before is it's not turning upside down in the server-side code. This is completely legitimate. Oh, hang on, no, it is failing on the server side, isn't it? This has nothing to do with Unity. This is being set. So yes, I reckon the this desired rotation, my guess is that its Y component is becoming negative when it goes bad. So let's just prove that. I will just let it run. We'll get it so that we know it's in a good or a bad state. If I come round here where we know it's good, I reckon I'll have positive Y. Yeah, I think you're absolutely right, Graphic. We pause on that. We've got the desired rotation has a Y component that's positive. But if it goes bad, let's make it go bad. I think that it is going to become negative. Bad? Yep, it's bad. We come back into here. We breakpoint here. Desired rotation has a Y component that's negative. Okay. So the dodgy, hacky fix to this, yes. The dodgy hack is to actually go const is upside down. It's going to be desired rotation dot y dot imag 1 less than 0. And then in here, I'm just going to put an is upside down and just negate it. So this will return negative angles when that thing flips upside down. I mean, this is just so hacky, it's not funny, but has our AI crashed? No, that processed one. Oh, promise. No, this is our AI has crashed. Okay, this looks better. Perfect. Yeah, I should comment that hack. Yeah, thank you. Hack. Oh, I'll do it as a to-do. There we go. Okay. So what I think I'll do is I'll get this so that he, rather than, I mean, he's turning slowly at the moment just because the tick processing speed is so slow. But I'll change the code now so that he actually turns slowly, and then I'll probably finish the stream up there. So, what I need to do, now this might lead to some jitter, but I want to use sort of a move to. Now, I think that these quaternions have a, I can't remember the name of the function. It's like a smoothing function on rotations. What's it called? Oh, here it is. No, this isn't. Yeah, slope is exactly what I'm after. It's spherical something. I can't remember what slope stands for. It's very interpolate between two quaternions. Yeah, this looks like what I want. No, it's not. And the reason it's not is I don't want a percentage. Yeah, any kind of thing like slurp or even a move to, you often end up with jitter at the end of it, and it's just the rounding of floating point numbers. There was actually a post on Twitter just recently suggesting a much better way of interpolating things, which is you, well, this kind of, by using a percent, it actually kind of gets there. But the idea is you say what your starting point is, what your ending point is, and then you track your percentage of the way along it. And the moment you get to 100%, you stop processing. The Twitter post, I'm not going to be able to find it easily, but it was originally suggesting it for as an alternative to Unity's move towards, whatever it is. But I am just going to use a basic move towards implementation here. Move towards the desired rotation. Const desired degrees is going to be equal to that. The tweet, do you mean, if man? Yeah, I can probably find it. It did come up in my towards Unity tip. Vector projection Unity. No, not going to be able to find it, I'm sorry. It did mention vector projection. Oh, here we go. Here is the tweet here. What I'll actually do is I will just retweet that. Yeah, follow me on Twitter. Island54 Games. Yeah. There we go. So we move toward the desired rotation. So in here, const current degrees is going to be equal to entity dot transform dot rotation dot y. Now I want to specify the maximum movement rate. Now maybe we say where's my troll? Rotation speed. Let's say that he can rotate by just 30 degrees per second. So in here, once maximum degrees is going to be the agent dot attributes dot rotation speed divided by the configuration dot tick dot frequency. So at a frequency of 1, we'll be able to turn at the rotation speed. At a frequency of 10, be able to move by. That tweet is for movement, correct. But I believe the same approach. You'd have to write your own slope function, but I believe the same approach can be used for rotation as well. Maybe. Yeah, no, I'm not sure about that. So maybe it's not all that relevant to the jitter on rotations. Certainly, because I'm not going to do a spherical interpolation here, I'm just doing a linear interpolation. So the approach could be used here, although it's only one dimension that I'm working with. Yeah, it's not all that relevant, I guess. But it's something I thought of when you mentioned it. Used before declaration. What have I done here? There we go. So maximum degrees is equal to that. We're going to do const new degrees. Let's go delta degrees first. Is the desired degrees minus I feel like you should get the quaternion from the current position and then resize it to the distance you want to travel per tick. Yes. Yeah, I could do that. It's an object spinning around a waypoint. The problem I have is I do ultimately want to cap the number of degrees that it can turn within a given tick. So it's not a matter of just applying a scaling factor to it, because keep in mind these functions have to be absolutely stateless. Change in angle. Position. Each tick. Yeah, I could do that. I think I'll just get this working first. Yes. I mean, when I get rid of Euler angles, because I don't want to be using Euler angles at all. Once I get rid of them, then, yeah, this all becomes a lot simpler. But for now, I think I will just do it like this. I do see what you're saying, and I think that is the better way of doing it. Destination hasn't changed. Yes. Yes. I think that's the better way of doing it. But for debuggability, I am just going to do it like this for now because I do have the desired rotation. I know that I'm only working in one plane at the moment. Okay, desired degrees minus the current degrees. And then, so that's how far we want to turn by. And then I can just say const new degrees is going to be equal to the math.max of, it's not as simple as math.max, is it? Because we could be moving in either direction. So I need to do this with a conditional, which is if math.abs of delta degrees is greater than max degrees, then I need to scale it down to the degrees with the correct sign. Is there a math.sign? There is a math.sign. Nice. I could have used that up in here. Math.sign of delta degrees times by max degrees. Otherwise, just return the delta degrees. So the logic here is if we want to move further than we're allowed to, then move by the maximum number of degrees, but in the correct direction. Otherwise, just move in the correct number of degrees. So we now do entity.transform.rotation.y is going to be equal to new degrees. Oops. Correct already. There we go. App crashed. Why is he crashed? Welcome to the stream, MHSTRE. Won't be going a huge amount longer today. Once I've got this troll to a point where you could kind of sneak up on him to some extent, dart around the back of him so that he can't attack you, then I'm probably going to finish up the stream at that point. Okay, where are we at? Here we are. Here's our troll. Oh, yeah, he is jittering around a bit, isn't he? No, this is just a straight out bug. He is thoroughly confused. Yeah, so on the topic of backstabbing, one of the things I want to be able to do, because we do have crouch in the game, I do want the aggro I do want it to be possible to avoid the aggro. So if you crouch from behind him, then I don't want him to aggro on you, so you should be able to come up behind him and attack him from there. He's turning half the distance between you and the starting position. Quite possibly. Ah, what have I done? I've lost my mouse. I've obviously pressed a key combination that did something else. Yeah, I think that... I mean, he's just alternating between two things. This is going to be something really dumb. Half the distance between you and the starting position. I don't think he is he? If we... he seems to always face... Oh, maybe you're right. Okay, what is going on here? debug. Desired yaw is bouncing around the place. It really shouldn't be. So let's get a breakpoint in here. Just breakpoint here. So his current degrees was 58. His maximum should be... Oh, not a number. Well, that is definitely not going to work. So no, he's working without any kind of physics. This is the first geometry that I've put into the game. He's just using the vectors at the moment to make decisions because this is all server-side. So he knows where the player is, but this is just a really simple problem. The troll that's in the game doesn't have a maximum... It's got an attack angle, but he doesn't have the maximum rotational speed. So I just need to delete him. Delete. I'll then put the troll back into the game. This command here. And then I need my troll. He has the rotational speed. Paste that in there. Yeah, so for anyone new to the stream, this is all being controlled by a server written in TypeScript. So the server itself doesn't have any of the niceties of Unity. But it should, in theory, be extremely scalable. Okay, so we now have a proper troll. It's not doing much now. Oh, something's crashed. Stop the server and restart it. Breakpoint's disabled over there so that I can get back here more easily. What on... Does he have... Oh no. There are two trolls. Okay, let's try that again. I'm going to stop the server. No, I can't stop the server yet. I need to delete the entities. I will restart the server. Yeah, I'm really looking forward to having people be able to kind of try out the game. At the moment, my focus is just to get a couple of compelling features in, so a little bit of combat and get the crafting back in. And then I'll need to get the server up to scratch because it's really quite unreliable at the moment. But then I'll look at getting some players actually into the game, which will be nice. Speed. Okay, hopefully we only have one troll now. Still flickering. Okay, so let's get this breakpoint in. His angle to target is 149. Current degrees is 30. That looks very suspicious. Maximum degrees is 30. This is going to be so dumb, isn't it? So we want to move by 45 degrees. He's not allowed to move by more than... Oh, this is so silly. I'm guessing Griffic already saw this. This needs to be a plus equals. No, equals, what is it, current degrees plus. Brackets around all that. All right, my AI is still running by the looks of things. Is it? Oh, I think my AI just crashed. Didn't like making the change live. Is the ticker running? The ticker is running, but it's not doing what I want. Breakpoint. Something is very unhappy here. Okay, something died. Is it a compile error? Yeah, no, that bug was just a simple, I was setting his rotation to the delta rather than changing his rotation by the delta. And the question is why did that just crash? It crashed. What am I doing wrong? Error. Fetch failed. I mean, that looks like the entity server is crashing. Oh, here we go. Oh, he's confused. He's going to go around the long way. Ah, yeah. Now, this is where Griffith's suggestion would have been a really, really, really good idea. The problem here is that when I cross the 0 point, when I overflow from 180 degrees down to minus 180 degrees, I'm getting a massive delta, like a big negative delta. Now, that wouldn't happen if I were doing this as a quaternion. Yeah, it's always the simple stuff that gets you. So the question is, do I want to... I've got to decide if I want to do this across the quaternions now or put in the logic to make this handle that wraparound. I'm tempted to do the hack. To do move this logic over to quaternions. This is awfully hacky. So what I've got to do in here is I've just got to say let delta degrees equal to that if delta degrees is greater than I can probably I'll tell you what I'll do. On delta degrees is going to be equal to just JavaScript support floating point modulo arithmetic. I'm just going to check that. Node 400.3 mod 360. See how their modulo behaves. That's 40. And if I go minus 400, I get minus 40. Beautiful. So I think I can just do this as modulo 360. No, it's still not quite right. Because if this were minus 350, I don't want it to go the long way around. In fact, if it's greater than 180, I want to invert it. All right. So if math.abs delta degrees is greater than 180, catch you around. Thank you for joining in. Do this pretty much every day, every weekday in Australia. And again, since I'm just being hacky, I'll just do two different cases. If delta degrees is greater than 180, then delta degrees minus equals 360. Else, if delta degrees less than 180, then delta degrees plus equals 360. I think that'll make him turn the right way. Hacky, hacky. I don't think that did what I wanted. Thank you. That would do it, Griffic. Okay, he turns to me. Come around here. He's looking better. Yep, this is looking really good. And if I come round too fast, he should turn back around the other way. Excellent. And he can't get us. Oh, he got me. That seemed a bit weird. I think I might have gone too far forward. A pretty ballerina or a spit roast, one or the other. Why is he not attacking me here? Oh, he is. All right, so we've got him turning to face us. Obviously, it's looking all jerky, and that's because of the combination of the tick speed, and I have no client-side buffering or interpolation. But I think that on the whole, it's looking better than it was. See, he's a bit more dynamic. I won't be working any further on this today. I'm going to go and do a bit of stuff for this weekend's devlog episode. But tomorrow I'll be back on and might start working on getting him the very long process of getting him to actually walk over the terrain, get some pathfinding in. So thank you everyone for joining. Anyone who's not subscribed, don't forget to subscribe to the YouTube channel. And thank you again for joining us. I look forward to seeing you all next time. Catch you around.